Let's go beyond just the answers. Here's how to add, subtract, multiply, divide, invert, and compare complex numbers, step by step. We'll use z1 equals 3 plus 2i and z2 equals 1 minus 4i all the way through. Addition. Combine like parts. Real parts add together, imaginary parts add together. They never mix, just like you wouldn't add 3 apples and 2 oranges into one number. So 3 plus 2i plus 1 minus 4i. Add the real parts, 3 plus 1. Add the imaginary parts, 2 plus negative 4. That gives us 4 minus 2i. Subtraction. Subtraction, same rule, just subtract instead. First, distribute the minus sign across both parts of the second number. Minus 1 minus 4i becomes minus 1 plus 4i. Now add as usual. 3 minus 1 is 2, and 2 plus 4 is 6. The answer is 2 plus 6i. Multiplication. Multiplication, treat the two numbers like binomials and multiply every term by every term. First, outer, inner, last. 3 times 1 gives 3. 3 times negative 4i gives negative 12i. 2i times 1 gives 2i. 2i times negative 4i gives negative 8i squared. Here's the key step. I squared equals negative 1, so negative 8i squared becomes positive 8. Combine everything. 3 minus 12i plus 2i plus 8. That's 11 minus 10i. Division. You can't leave I in the denominator, so multiply top and bottom by the denominator's conjugate. Same real part, flipped sign on the imaginary part. The conjugate of 1 minus 4i is 1 plus 4i. Multiply the bottom. 1 squared plus 4 squared equals 17, a real number, no more I. Multiply the top. 3 plus 2i times 1 plus 4i equals 3 plus 12i plus 2i plus 8i squared, which simplifies to negative 5 plus 14i. Divide both parts by 17. Negative 5 over 17 plus 14 over 17i. Multiplicative inverse. Multiplicative inverse. This is really just division with 1 on top. 1 divided by z1 equals the conjugate of z1 divided by the modulus squared. The conjugate of 3 plus 2i is 3 minus 2i. The modulus squared is 3 squared plus 2 squared equals 13. So the inverse is 3 over 13 minus 2 over 13i. In comparison, real numbers sit on one line, so you can always say 1 is bigger. But complex numbers live on a two-dimensional plane. There's no direction that counts as more. So z1 is greater than z2 has no meaning. What you can compare is distance from the origin, the modulus. The modulus of z1 is the square root of 3 squared plus 2 squared, about 3.61. The modulus of z2 is the square root of 1 squared plus 4 squared, about 4.12. Since 4.12 is bigger, z2 is farther from the origin. That's the only kind of bigger that applies. Add or subtract the matching parts. Multiply like binomials using I squared equals negative 1. Divide or invert using the conjugate. And compare only the moduli, never the numbers themselves.